All right, so let me get this going and we'll load up the other screen. All right, so the new project we're calling the Cam Toy Project because it is a toy that uses a cam mechanism, which let's take a look at what the final product is going to look like. Did I lose it already? Shoot. Where would it be? Oh, I have it on the spreadsheet. I think I showed it to you briefly yesterday. And it is going to look enthusiasm. And it's going to look like this, where we are hopefully going to get into some sort of the camera animations. It's taking forever to load. Come on. Okay, but the basic idea is the working mechanism with the lifting situation. You don't have to do something that is this as complex as that example, but it's not terribly difficult. Some other examples. This one is a little more complex just because the shape of the cam is what determines the action. And there's some extra stuff going on there. And let's see. This one was actually unbelievably difficult to do, but you know, still it works. So let's see if we can shrink this. Nope, that's too big. Wish I had some more pixels to work with. But and when you record it, it looks a little bit cleaner. But you can see the offset of the cams, which are the moving parts, are what's causing it. Just a little background to it. A cam is a mechanical part that takes rotational motion and turns it into linear motion. You maybe have heard of a camshaft in an engine that turns off a pulley from the crank that opens and closes intake and exhaust valves. That's probably the most common place that the average person will see or hear it, but it's usually an egg shape. But in our sake, or for our case, it really can be anything that takes the theoretical or whatever implied motion of the toy's crank and turns it into a reciprocal motion of up and back, down motion. Okay, so we'll go through right now a couple of good places to start. And yours doesn't have to be exactly like the one I'm about to show you or one of the ones that I'm currently showing you, but it's a good place to start. So we'll start by making the base here with some really generic dimensions. And the next step after you make the base is going to be to start the assembly. Even though you only have one part, start the assembly and start placing things as you go. Okay, so we'll start with a new part file. Just to recreate that base, I'm going to make a sketch, and this is the front. And for these, the bases that I've made, which again, they don't have to be exactly, I'm going to call this the front, that view. So I'm going to make a rectangle that is, let's go 12 wide and 6 tall. And then we can extrude it. That's fine. Extrude it 6. Okay. And then there's a couple ways you can cut it out. I'm going to use the shell tool from the bottom, which you can see from the little pictograph there, it keeps everything except sort of carves it out from whatever side you choose. And the only dimension is that thickness. I'm going to leave 1/4 inch thickness all the way around. Then for the cutouts on the side, I'm going to put a new sketch on the side, or technically the front. You can see where I'm sketching. I'm going to use the offset tool and click on the edge, then go in, click again, and then set the dimension between any one of these lines and its nearest line to, this will be the thickness of that vertical part. I'll just do another 1/4 inch there and finish sketch. Extrude. What happened? Is that? Oh no, that's right. Extrude this, switch it to cut and cut through all. And this one is important to do through all instead of just 6, even though 6 will do the trick. Using these sort of generic distances like through all or to next or something like that will allow you to change the dimensions later, which if you do it that way, it's going to be really easy to change the dimensions and move like the hole around or the location of the crank and that sort of thing. Switch it to cut, cut all, hit OK. Now we need a hole for the crank that goes all the way through. So we'll put a sketch here. And let's just have it centered. Let's have a 1/4 inch dowel, maybe 3/8 would be a bit easier to see. And let's center it. This is 6 by 6, so that means it's 3 from the side. You don't need to log in, just hang out for a second. And 3 from the top, and this will be easy to change, but this is just a generic location for things. Finish sketch, extrude, choose that, switch it to cut and cut through all. And let's just put one hole in the top so that, it's almost definitely, I don't even have a plan for this one yet as far as what the actual design is going to be. But I know my lifter, which is that the vertical reciprocal up down thing, I want to be a 1/2 inch. And based on your design, maybe you think it looks a lot better if the lifter is a lot thinner. Like on this one, the lifter is super thin, which goes through the the chopped log there. But I'll just start with the 1/2 inch one, and I know I want this to be centered. So that's 3 off from the side. And as far as the location going left or right, not super critical depending on what your design is again, okay, or your idea. So we'll choose that, switch it to cut, and I mean at this point the distance doesn't really matter. All right, so that's actually it for the base. So let's save this. Let's put it in a location I can find it. Let's go up to here. Let's call this CAM P6 and save that. Okay, so we have this part file. We'll leave it open, and we're going to go ahead and start an assembly file and place it in there. I highly recommend if you go to Tools, Application Options, yours will probably be on the back row, Assembly, Tools, or Settings. Turn on Place in Ground First Component at Origin. This will have it so that when you bring something in, which will probably be your base, it will be locked in place and everything else will be moved around it, which makes it a lot easier than having stuff pop all over the place. Save you time. Okay, so let's go ahead and place the item, which is, it's up here at the top. P6, and let's place it. Okay, and we only need one, so right click OK. All right, so now let's do crankshaft. So we're in a new part, and let's just start with the long dowel, which is going to be, you don't need to log on, just hang on for a second. I think I made it 3/8 of an inch. And the whole thing is 12, so I want it to stick out a little bit on both sides. So let's try 13. And then we need some sort of offset handle situation. There's a bunch of ways you can handle this, but I'm going to do something like this, where, and this part isn't going to interact with anything, so it doesn't matter if it's egg shaped or whatever. Let's extrude this 0.5, and this might actually look weird, whatever. And we'll do a little smaller part on this. Let's make this 0.25 again, and extrude that 1 inch. And I actually think it's probably look better if I go back to this second extrusion, edit sketch, right click, edit sketch, and put it on top of that. That looked a little awkward, and that's good enough. And so we'll save it. Let's call it crank P6. And we'll go back to the assembly and place components. Okay, and we've done insert constraints before. This is very close to the mini train situation where we're gonna do a constraint and we want to do an axis constraint, not a edge constraint or center point constraint or a face. This is, we want to make this axis to the axis of the hole that goes all the way through. Hit okay. It doesn't matter which direction it's facing at this point, but we do want it to be sort of balanced and not have it come out. We're going to have to spin it later, so we're not going to have an angle constraint on it yet, but let's do a bit of an offset. I have it, it's 13 inches long. The whole thing is 12 to the outside. So let's do a 1/2 inch offset. And I'm going to just change the color barely so that it's easier to see from a distance. What's the color? Don't use the thin ones. I thought it was going to be faster. There we go. All right, so save it. Okay. The next step, and this is where I'm going to end for today, is to make the cams, which are going to be sort of an egg shaped and locked to the crankshaft, but the key is the angle constraint. The next part where we actually build the lifter and constrain the lifter to the cam is going to be a little more complex. This point, all we need to know is that the diameter of the crank is 0.375. So that's going to be the size of the through hole for the cam. You start a new part. Let's start a sketch, and this plane is fine. And it will help you a lot if you make your parts centered on 0, 0, because then you can use the origin planes for your constraints without having to make a new one, which is what we're going to do here in a second. But let's dimension this to 0.375, and the rest of it needs to go around the outside. I'm going to recommend starting with just a circle. Technically, you could use an ellipse. The problem, and I've shown you the other ones where it's like a partial ellipse and then like a slanted thing. Inventor interprets those connections differently, and sometimes it breaks. But actually, let's just go ahead and start with an ellipse. Have it centered a little bit above and offset like that. And we'll finish sketch, extrude, and I'm just guessing on dimensions. And I want to extrude everything except that hole. And I think 0.5 will probably be okay. And let's save this. And let's call it cam 1P6. And let's give this a different color. Your color schemes will be determined by what your design is. It doesn't really matter. And so we'll save this, and let's go back to the assembly, place components, place cam 1P6. Choose your names appropriately. Okay, and the first constraint for this one is the axis. We know we want that. And need to make sure that it's not too big. And next one, could have done, can you constrain a face to an axis? Oh, well, that's not too bad. That's one way to do it. The other way to do it, the way that I would normally do it, is just to do a mate of this to that and set an offset of whatever it should be so that it lines up with the hole, which right now this is 4. So if I went back to the base and I edited, and this is where being able to edit it makes it a lot easier. We'll edit the sketch. And I honestly am not sure which direction it is 4 from, but it's 4 from the inside. Plus it's the thickness. So I think it still is going to be 4 if you have to back out the other one, assuming it's going the correct direction. And of course it's not. Let's just edit. I don't know. You can really just line it up and do a line it up the way, don't freeze. Oh, do not freeze. Okay. Line it up so that it looks right. And then do a whatever it's called, guess and or predict and orient. So you do constrain, mate this face to this face. And as long as you have this check mark on before you select it, it will put in the offset so that it will be constrained wherever it is right now. And apparently it's 3.548, whatever, from there. Okay, so now we have this. We just need to make it so that this turns when this turns. So we're going to go back to the crank and turn on one of its origin planes, one that goes lengthwise, either this one or this one. I'm going to turn on the visibility of this one. We'll go back to the cam and turn on one of the planes that goes lengthwise, either this one or this one. I think this is the obvious choice for that. Go back to the assembly, and we just need to mate or flush whichever one lines it up. And we don't need to do predict and offset for this, but we should be able to just mate that. I think it might be flush actually, now that I think about it. Oh, well, there we go. Hit OK. And now they should turn together. And if you want if your design is going to have 2 things that are offset, there's going to be a lot of playing back and forth and adjusting as you go, but it would be the same basic idea where instead of just a mate, you would do an angle constraint. Really, technically, it should be an angle constraint, but it's fine the way it is. Let's go ahead and do a predict and offset that. And the reason why is because we're going to do angle constraints later, and that's how we're going to animate and do a rotation animation using the angle constraint. But the angle constraint is just this type. Choose the first solution, the only one with 2, and choose this. And if you have predict and offset, it will give you whatever angle it is, which apparently is 143.09. And when you turn, it will turn offset. And that's how you get something like this, where one goes up well after or before the other one. And it will you'll all be able to adjust it by finding that constraint. And I don't know, 45, maybe 45 is the right amount. Okay, depending on what's going on. And that's where we're going to end it for today. Because the next part where you're actually attaching something to follow the cam as it spins is a lot more complicated and requires a little bit of a finicky baby steps. So we'll end it there. So go ahead and you can start thinking about ideas. Remember, the key is starting with a base. And as soon as you're done with a basic base, start the assembly and start throwing things into it as you make them. All right, that's it. Get to work for now.